And the most mysterious of all is the red planet, Mars.
In the late 90s, the Mars Global Surveyor spacecraft, which was in orbit around Mars, had a magnetometer aboard. That magnetometer found that Mars does not have a global magnetic field.
But the Mars surveyor found evidence of small magnetic fields scattered on the face of the planet. NASA believed it was paleomagnetism, an ancient remnant from a period billions of years ago. Did Mars once have a magnetic field rivaling Earth's? And if so, what happened to it? Fortunately, we don't have to go to the red planet to investigate, because pieces of the red planet are already here.
We actually have samples, rocks from Mars. They're meteorites. They were blasted off of Mars by an asteroid or comet impact millions of years ago. These rocks wandered around in space, and then some of them landed on the Earth randomly.
One of these Martian meteorites is actually famous. ALH 84001. Some scientists have suggested it contains the remains of ancient Martian life forms. Whether or not this proves true, this piece of rock may answer the question of Martian magnetism.
ALH 84001 is the oldest known rock from any planet, and it is a unique sample from Mars. It lived through the earliest epoch of Martian history. So this sample has all kinds of fascinating records in it.
MIT's Superconducting Quantum Microscope, or SQUID, is one of the most sensitive magnetic detection devices on Earth. A sample from the Martian meteorite gives up startling results under the SQUID lens.
We showed that this rock is magnetized, and the magnetism, the paleomagnetism, has been very precisely dated to be about 4 billion years old.
Beneath the surface of the meteorite is the ancient record of Mars' magnetosphere. 4 billion years ago, a strong magnetic field was generated by churning magma in the planet's core.
Early magnetic Mars was a fundamentally different place than the one we see today. The atmosphere, we think at that time, was much thicker than it is today. There was probably water flowing on the surface. Temperatures were warmer. So it was much more Earth-like.
Then, mysteriously, Mars died. Temperatures dropped. Water vanished. The atmosphere disappeared. What happened?
Mars' magnetic field died sometime around 4.1 billion years ago. What's really fascinating about that is it seems to be roughly coincident with the time when Mars began to change from an early warm, wet state to its current cold and dry conditions.
One hypothesis for why Mars' atmosphere disappeared was because it didn't have a magnetosphere to help protect it. So the solar wind was constantly stripping away parts of the Mars atmosphere.
Without magnetic armor, a coronal mass ejection would bombard Mars' surface, a magnetic hurricane that would tear away the planet's atmosphere.
Suddenly the atmosphere was losing large quantities of gases like oxygen, argon, nitrogen. The atmosphere got thinner over time. Liquid water stopped being stable on the surface, and Mars kind of went into a stasis, a cold, dry stasis.